Welcome to my channel. So let's have a look at today's challenge problem 1465. Maximum area of a piece of cake after horizontal and vertical cuts. So overall the problem is that we cut a cake into smaller pieces horizontally and vertically. Then we find the largest piece or largest pieces. So for this problem, we shall give a grading method, and we'll first read through the statement of the problem and look at the example and emphasize 2 points, and then we share the code and do the tests. First, let's have a look at the problem statement. So we are given a rectangular cake of size h times w and two arrays of integers, horizontal cuts and vertical cuts, where the horizontal cuts I is the distance from the top of the rectangular cake to the ith horizontal cut, and similarly vertical cuts j is the distance from the left of the rectangular cake to the jth vertical cut. So we are required to return the maximum area of a piece of cake after we cut at each horizontal and vertical position provided in the arrays. Since the answer can be a large number, so we are required to return the result in the sense of modulo 10 to the power 9 plus 7. So that's the statement of the problem. So let's look at the examples. So in example 1, so the horizontal cuts is at 1, 2, 4. So and the vertical cuts is at 1, 3. So the largest area is 4. So in example 2, so the horizontal cut is 1 and 3, and the vertical cut is 1. So the largest area is 6, which can be this green part or can be the yellow parts. So comparing with the two examples, we notice the following point. First, the horizontal cuts and the vertical cuts are not necessarily sorted at the very beginning. For example, in example 2, the horizontal cuts is not sorted. And the second, so assume that we have n cuts horizontally or vertically. Then we cut the cake in that direction by n plus 1 pieces. For example, here in example 2, we have two elements in the horizontal cuts. Then horizontally we cut the cake into 3 parts, from 0 to 1, and 1 to 3, and 3 to the end, 5. So that's 2 points we need to notice. So once these 2 points are noticed, the problem should be straightforward. So before we do the code, let's look at the constraints. So the first constraint is about the range of the height and width for the cake, and the second and the third one is about the length of the cuts. So both bounded above by 10 to the power 5th, not a small number, we'll see. And all the elements in the horizontal cuts or in the vertical cuts are distinct respectively. So that's also an important assumption. But sometimes we can think if there are repeated elements in the horizontal cuts or vertical cuts, it will produce 0 height or width. So that's not an important or interesting element. So if we have that, actually, we can exclude that by doing a set operation. So, but that's not very relevant to this problem. So with that aside, let's look at the solution. So the method, if we want to impose a name to the method, I would say it's a grading method. And the idea is very simple. So the area is the small height times the small width after the cuts. So we want to maximize this area. Therefore, we should make all the small heights and the small widths as large as possible, and find the largest one respectively, and then do the products. So that's the straightforward idea. However, we shouldn't forget that. So in a cart, it has a small height from the 0 to the smallest cart, and also another one from the last cart to the height or width. So we shouldn't forget that part. So both horizontally and vertically. So once this point is also noticed, I guess the solution to this problem is sort of straightforward. First, I'm going to do the preparation. So for the preparation, basically, I would like to first sort this this cart list. So here I changed the name a little bit to make it easy to write. So horizontal carts and vertical carts. So first, I'm going to sort the two carts in place, and then also we'll sort this one in place, and then I want to append the height and width to the two lists accordingly in order to take care of the last small height and last small width. So here I'm going to do append. So H. So here vertical carts append W. So with that said, we are going to find the smallest, the largest small height and largest small width. So step 2, find largest small height and width. So for this purpose, let me first do the horizontal carts. So for the horizontal carts, the first small one is maximum height, let's see, is the first element in each cart. In other words, from the beginning to the first cart. So then we just need to do a linear scan. So for I in range, so I'm going to start from 1, then ending at length of each cart. So we are going to reset the smallest, largest height, or we want to reset the max h variable. So it's going to be the maximum of all the possible small heights. So the current small height actually is h carts I minus h carts I minus 1. So this is also the reason that we start from 1. So this will determine the maximum small height. Let's determine the maximum small width. So that's the v carts 0. Then same iteration for I in range, starting from 1 to length. So v carts. Then the maximum v w is a maximum the previous state, then times the current one, that is v carts I minus v carts I minus 1. So once these two steps are done, so basically we can do the return. So what we are going to return is the maximum height times the maximum width. But do not forget that we should modulo this result by a big number, that is 10 to the power 9 plus 7. So let's check a special case and then do the generic case check. Yeah, it passes the first example. Now let's do a generic case check. It passes the generic case. So actually, in my first try, I forgot to modulo this large number. So let's have a quick summary. So the method is greedy, and we want to try to find the largest small height and the largest small width, and then return their product modulo the corresponding number specified by the problem. So I guess the main part for this problem is the sorting operation. And once we did the sort, and then finding the smallest, the largest small height and the largest small width is basically a linear scan, and then we do the return. So that's about it for this daily challenge problem. Thank you very much.